Think of the most dedicated student you know. They're at their desk, staring down a mountain of textbooks, reading the same paragraphs over and over, writing out flashcards until their hand cramps. They are doing absolutely everything right according to the standard advice we've all been given. Yet somehow, a week later, the information just evaporates. They hit a wall, and no matter how many hours they put in, they can't seem to break through to actual mastery. We've been told to follow these ancient learning rules since grade school. You write your notes out by hand 10 times. You obsessively practice one single skill until you're perfect. You memorize the definitions until you can recite them in your sleep. But decades of cognitive research paints a very different picture. When scientists actually measure the impact of these deeply ingrained habits, they find that sheer repetition and blind practice account for a shockingly small percentage of how good someone actually becomes at their craft. The problem is rooted in our biology. Our brains are highly efficient biological machines designed to conserve energy. If a task feels repetitive or easy, the brain switches onto autopilot to remove cognitive friction. And an autopilot brain does not build new memories. So all that massive effort, the hours of reading and highlighting, gets squeezed down into a biological dead end. Researchers call this state shallow processing. You aren't failing because you lack discipline. You're failing because your study methods are actively telling your brain to shut off. You have probably heard that mastering a skill takes 10,000 hours of practice. That idea stems from a famous 1993 study tracking elite musicians at the Berlin Music Academy, which concluded that the highest performers simply accumulated the most hours of practice by age 20. But later meta-analyses exposed a massive flaw in applying this rule everywhere. While raw practice time explains about 20% of performance differences in highly structured fields like chess or music, that number plummets to a mere 1% for professional tasks like computer programming. We see the exact same illusion of effort when it comes to taking notes. In 2014, a massive study called "The Pen is Mightier Than the Keyboard" declared that taking your notes by hand easily beats typing them on a laptop. People assumed the physical act of holding a pen was creating the memory, but the true mechanism was entirely different. Writing by hand is slow. Because you cannot write fast enough to transcribe every word a speaker says, you are forced to summarize it. You have to paraphrase it and condense it on the fly. This is exactly why using an AI tool to perfectly transcribe a meeting or a lecture actively harms your ability to learn the material. It removes the struggle. Without the mental bottleneck of trying to translate someone else's words into your own, your brain skips the encoding phase. Trying to make learning effortless, whether through robotic repetition or automated transcription, ensures your brain stays in that shallow processing state. You're left with brittle memories that vanish the moment you actually need to use them. To see how real memory is built, let's map out the structure of a classic 1969 experiment. Researchers gave participants a simple list of words. One group was told to memorize the list. Another group wasn't told to learn anything at all. They were just asked to rate whether each word felt pleasant or unpleasant. When tested later, the group rating the words performed at the exact same level, or even better, than the group agonizing over memorization. By evaluating a word's pleasantness, they had to compare it against their own life experiences. They accidentally built a highly connected network of information, known as a schema. This is deep processing. In order to construct a durable memory, your brain has to actively interpret data, search for patterns, and tie new concepts to things you already know. True understanding isn't the goal of learning. It is a direct byproduct of this deep, active processing. We can see the real-world consequences of this in a 2010 study of cadets taking introductory calculus at the Air Force Academy. Researchers looked at how students rated their professors' teaching styles and then tracked those students' long-term academic success. The cadets who had highly rated, engaging professors who made the introductory material feel perfectly manageable did great in that specific class. But when those same students moved on to advanced calculus, they severely underperformed compared to peers who had struggled through classes with less accommodating teachers. When a topic feels difficult, we tend to blame the teacher or the textbook. But that difficulty is the exact mechanism of growth. Cognitive friction, that uncomfortable, frustrating sensation of trying to wrap your head around a heavy concept, is the mandatory physical sensation of your brain actively weaving a durable schema. Knowing how to trigger deep processing in a classroom is one thing, but how does this translate into the real world, where the ultimate goal is to develop expert-level intuition? Author David Epstein points out a major flaw in how we pursue expertise. We assume that hyper-specializing in one narrow domain from day one is the fastest route to the top. But in dynamic fields, without fixed rules, locking yourself into one highly specialized track makes it incredibly difficult to adapt. If you practice the exact same skill in the exact same way for 100 hours, you hit a plateau. True experts rely on generalized practice, applying their skills across a variety of unpredictable scenarios. This builds conditional knowledge, the crucial ability to know exactly when to deploy a specific tool, rather than just knowing how to use it. In 2009, researchers Daniel Kahneman and Gary Klein investigated how experience actually translates into that expert intuition. They found that merely putting in the time guarantees nothing but overconfidence, unless you are operating under very specific conditions. To develop accurate intuition, you must be in a high-validity environment. This means the rules of the game are stable, and crucially, you get immediate, undeniable feedback on your actions. If you make a bad move in chess, your piece is instantly captured. You learn immediately. But if you spend years making decisions in a low-feedback environment, like picking stocks or diagnosing complex issues where the results aren't clear for months, your brain doesn't get the friction it needs to correct itself. You build a massive reserve of blind confidence without the competence to back it up. If you want to accelerate your learning and master complex skills, you have to stop trying to make the process easy. Stop writing mindless flashcards. Stop letting software do your thinking. Take the floaties off, seek out immediate, harsh feedback, and embrace the friction of deep processing.